Now let's talk about how we can show a graph. So we have the graph G with 4 vertices A, B, and C and D, and also the edges that connects these 4 nodes together. So one way to show a graph is using a list of edges. So for example, we can say that we have graph G with vertices in edges, that is edge A to C, C to B, C to D. So as you see, there are 3 edges and we have all edges listed. So if we are given this list of edges, so we can easily draw the graph. Okay, here, because the graph is undirected, there is no difference in writing AC or like CA, C comma A or A comma C, because the graph is undirected. But if the graph is directed, we have to make sure that the node, the direction is correct. So the source should be first and the destination should be second. So if there is a node, G is a directed graph and there is an edge that goes from A to C, then we cannot write this as C to A unless there exists another edge that goes from C to A. But for now, because the graph is undirected, so we can write it A comma C or CA also for the rest of the edges that we have. So this is showing a graph using the edge list. Also, we have the adjacency list. That is, for every vertex that we have, we are listing all the adjacent vertices. So for example, for A, okay, so I'm gonna just write it with A, that's stands for the adjacency of the node A. Then this is gonna be all nodes that are connected to A, or A goes from A to that other vertices. So it's gonna be only C, because there is only one edge that connects A to any other node, that is only AC. And the adjacency list for C will be A, will be B, and also will be D, because C is connected to A, B, and D. And for B will be only C, because B is only connected to C, and also for D, similar to A, and D is only gonna be C, because A is only connected to C. So that's showing the graph using the adjacency list. So if you are given this adjacency list, so we can easily draw the graph G. And the other one is using an adjacency matrix. So we can draw all the things that we have here. So we have A, B, C, and D here. Also A, B, C, and D here. In this graph, there is no edges from each node to itself, so we are gonna put here 0, 0, 0, and 0. It means that there is no path or no edges from A to itself, okay, from just directly from any node to itself. So from A to B, there is no direct edge, so we are putting 0 here. For to A to C, there is A to C is 1, okay, because there is one edge, and from A to D there is no edges, so it's gonna be 0. Okay, so you should be careful that we are not talking about the path. So here the adjacency matrix says that if there is a direct edge that connects any two vertices that you're considering, so there is no direct edge that connects A and D, so we are putting 0 for that. And from B to A, there is no one. From B to B we set 0, from B to C is 1, and from B to D also 1. And as you see, there is a there's an edge from C to A, from C to B, no edge from C to C, and also from C to D. There is no edge from C to A, C to B, but there's one edge from D to C. So that's our adjacency matrix that says that what are the connection between any two vertices we have in graph G. Now let's assume that our graph is weighted. So the cost of going from A to C is equal to 5. Sorry about that. So it's equal to 5. So the cost of going from A to C or from C to A is equal to 5. So here in the adjacency matrix, I'm going to replace 1 with 5. And from C to A also equal to 5. So it says that the cost or the from the C to A or A to C is equal to 5. If our graph is directed, let's say that we have from C to B here, and the cost is 2, so I'm gonna update from C to B equal to 2 here. Let's draw with another color. So I'm gonna say 2. And let's say also there's an edge from B to C with another cost, let's say 6. So here from B to C, I'm gonna update this one with the cost 6. Okay. So based on our graph that if it's undirected, so we are putting 1 to show that there is an edge from two vertices. And because it's undirected, if there is an edge from A to B, also there will be an edge from B to A. If the graph is directed, we should be careful about like putting the numbers in our adjacency matrix. If there's like an edge from a node A to C, then we can put it 1, but if there's no edge from C to A, then we have to put 0 as the corresponding number. Also, if our graph is weighted, like the graph that we have here, so and also directed, we have to be careful about the numbers that we're putting, and the numbers will show the values. So we can put 0, the cost, or we can put infinity depending on the problem. Here we are going to say it's going to 0. It means that there is no edges from A to B. Okay, and here A to C is equal to 5. That says that the cost from going to A to C is equal to 5. Also from C to A is equal to 5. But from C to B, as we said, is equal to 2. But from B to C is equal to number 6. Okay, so that's another way of showing the graph using adjacency matrix.